Hello. Today we'll be talking about 7.1, which is sequences and series. And there we go. Okay. Let me turn off some of these things. So the first thing we're going to discuss is a sequence. So a sequence is obviously just a pattern of numbers. So it could be as simple as just 2, 4, 6, 8, 10, and so on. Okay, these sequences can either be finite, meaning it has an end, or if it's not finite or it doesn't have an end, then that means it would be instead infinite, which means it goes on forever. Okay, again, finite meaning has an end, or infinite meaning it goes on forever. So if we look at this top sequence, this being 2, 4, 6, 8, 10, dot, 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 because those dots, I'm saying that I'm continuing on. I'm not saying that there's going to be an end to this. So that means it would be an infinite sequence. If I took these dots away and just said it was 2, 4, 6, 8, 10, that would be a finite sequence because it does have a definite end there, okay? So today what we're going to do is write a rule for these. So in the past, you probably said that you were just describing the pattern for a sequence. So here you'd say, oh, it goes up by 2 every single time. And that's great. You're recognizing that pattern that's happening within that sequence, but it's not a rule for the sequence. It's how the sequence progresses on. But what if I asked you, well, what's the what's the 150th term of this sequence? You would not be able to tell me without saying, well, gee, I don't know, let me write the next terms of this sequence to figure that out. Or I want it to be so that if you want to know the 150th term, you can just say, oop, let me plug this into an equation and boom, I have my 150th term. You should be able to have that within seconds. So to do that, we need to be able to write a rule. So these rules will vary. I'm going to show you what one is before we go ahead and write this ourselves. So we're going to kind of go backwards here. I'm going to tell you 2 rules of sequences. The first rule is a sub n equals 2n plus 3. The second one is a sub n equals -3 to the n minus 1. What I want you to do with both of these is to write the first 4 terms, okay? So what happens here is when we have this a sub n, it's basically representing what term in the sequence is that particular number for. So if it was a sub 1, it would be standing for the first term. If it was a sub 2, it would be the second term. A sub 3, it would be the third term. Okay, so whatever you're putting in for n, if it's your a sub 3, that's your third term, you plug in a 3 for n. Okay, so for instance, I have a sub 1, 2, 3, 4, because I want to find the first 4 terms. So again, whatever is in for my n in my subscript is in for my n in my equation or my rule for this sequence. I gave you the rule. I want you to apply that rule to find the terms of this sequence. So 2 times n plus 3 for a sub 1 is going to be 2 times 1 plus 3. 2 times 1 is 2 plus 3 is 5. So the first term of the sequence would be 5. And you can carry this out for the other 4 terms. So 2 times 2 is 4, plus 3 is 7. 2 times 3 is 6, plus 3 is 9. And 2 times 4 is 8, plus 3 is 11. So this actual sequence would be written 5, 7, 9, 11. And in your head, you can say like, well, awesome, it just starts at 5 and it goes up by 2 every time, like easy. But if I ask you to find the 25th term doing this, you have to write out all 25 terms. With this rule, you could just say, ooh, if I want to know the 25th term, that would be A sub 25, which would be 2 times 25 plus 3. So I know my 25th term would be 53. And it's just that easy versus having to count out, well, here's my first term, my second term, my third term, my fourth term, and getting all the way up to 25. Okay? So let's go ahead and do that for this other rule as well. Sometimes it's really helpful to see what some of these rules look like in order to go try to write these rules on your own. So in this first one, again, first term is 1, so I'm putting in a 1 for n. So -3 to the 1 minus 1 would be -3 to the 0 power. Anything to the 0 power equals 1. So it's just going to be 1 there. Next one, putting in 2 for n, -3 to the first power. -3 to that first would just be itself. So it would still be -3. -3, this one would be 3 minus 1, so -3 squared. Any negative to an even exponent is going to become positive. So this is +9. And last one would be -3 to the third power. Negative exponents to an odd power will remain negative. So this one would be -27. Okay, so some things I want to point out to you here. In this first rule, we have multiplication and addition. Multiplication jumps me out for my first term to not start at a low number, like not 1, 2, or 3. I start at 5 with this one. And addition makes me go up by just a couple every time. So this low pattern, not increasing by a ton, had a mixture of addition and multiplication. Whereas over here, we go from 1 to -3 to 9 to -27. So two things, these numbers in themselves are increasing pretty rapidly. When you see an increase, a rapid increase in number, you are likely dealing with some sort of exponent here. Okay, so you can notice here, we have exponents. That's going to cause us to increase rapidly. Second thing, if you ever see a pattern of positive, negative, and if I continued on, you would see positive, negative. You see that pattern happening, you are very absolutely having to use some sort of negative associated with an exponent. That jump between positive, negative won't happen without that exponent and some negative being contributed in there, okay? So this is applying a rule. If you're given a rule, you can go ahead and apply it. Again, if I asked you what the 501 term is here, you could plug 501 in for n. It's going to be a massive number, but you could find it. Okay, so now we're going to go backwards, and I want you to take these rules and write them on your own. Or take these sequences and write a rule for them on your own. Okay, so we're going to have a couple different sequences up here. The first one being 2, 4, 6, 8, 10, 12. First thing to note, this is an ending sequence. It ends at 12, so it is a finite sequence. Okay, just some terminology there. Second thing that I want to pick up on is 1. I don't start at 1, so there's likely going to be some addition and multiplication here. But also, I'm not increasing very rapidly. I'm going up by 2 every time. So again, likely no exponents or factorials or anything like that happening here. Okay, so when we write a rule, it has to be associated to the term number. So in this one, my n equals 1, okay, because it's my first term. In this second one, my n equals 2, because it's my second term. Third one, n equals 3, and then 4, and then 5, and then 6. Okay, so I always like to remind you to go double check with your n value. If you're not double checking this with your n value, I'm going to end up having you tell me, well, start at 2 and go up by 2 every time. That's a pattern and it's great, but it's not a rule for this sequence. So in other words, n has to be in that rule. It has to be 2 times n, 2 plus n, something to the n power, n factorial, n has to be within your sequence or this rule for your sequence, okay? So to write this a sub n, I want to know how do I get from 1, or my n value, to 2? So there's a couple different options here. To get from 1 to 2, I could have added 1. I could have multiplied by 2. Those are the two huge ones that I'm seeing here. Obviously, there's other things you could have done. You could have taken n to the n power, like 1 to the first power plus 1. There's lots of weird things happening, but the obvious ones for this first term is either adding 1 or multiply by 2. So that works for my first term. Now what I'm going to do is go check, does that work for my other terms? So if I took 2 and I added 1, does that get me to 4? The answer is no. But if I took 2 and multiplied by 2, sure, that gets me to 4. Okay. 3 plus 1, yep, the whole plus 1 thing's not working, but 3 times 2, that gets me to 6. 4 times 2 is 8, 5 times 2 is 10, 6 times 2 is 12. So what I'm seeing is if I simply take my n value and multiply it by 2, I'm getting to that actual number in that sequence. So you could write this as n times 2 or just simply 2n, right? It means the exact same thing. So in this case, if I did ask you, well, what's my 500th term? You could say, yeah, a sub 500 equals 2 times 500. That term is going to be 1,000, okay? If you cannot use your rule to find some far out term, it's not a correct rule. All right. Very good on that one. Okay, let's try another one. Let's do -4, -8, -12, -16. So a super obvious thing that's happening here is there has to be some sort of negative. So when I know when I'm writing my a sub n, one thing I need is a negative. I'm going down by 4 every time, so the number 4 probably means something here. Again, it has to be associated to my n value, so I'm likely not just taking n and subtracting 4 every time, okay? So if I have n equals 1, 2, 3, and 4, keep in mind, how am I getting from 1 to 4, 2 to 8, 3 to 12, 4 to 16? Okay, we want to know what is happening there. So I'm not going up a substantial amount, so I'm probably not dealing with an exponent. I'm probably dealing with something more like multiplication, addition, subtraction, something like that. So to get from 1 to 4 to -4, specifically, I know I have to have a negative. 1 to -4, excuse me, there's a couple of things I could do. The first thing I could do is simply subtract 5. 1 minus 5 would get me -4. Let me see if that works for the other ones. 2 minus -5 is not -8. 3 minus 5 is also not -12. So that one's not working. What I could also do is take 1 and multiply by -4. Okay, so that 1 times -4 is -4. Let's see if it works with our other terms. 2 times -4 is -8, so it seems to be working. 3 times -4 is -12, and 4 times -4 is -16. So that is the rule that seems to be working. Okay, so what I did is I took my n value and I multiplied every time by -4, meaning -4n would be my rule, right? And again, you can find your 5,000th or 500th or 50th term if you want to. Okay, let's try another one. A sub n equals 1/2, 2/3, 3/4, 4/5, and 5/6. So when you're dealing with a fraction, you likely want to deal with your top as a whole different rule, and your denominator is a whole different rule. Okay, so let's look at just my tops with my n equals 1, 2, 3, 4, and 5. Okay, I'm gonna deal with this as two separate rules, numerator versus denominator. So in my numerator, to get from 1 to 1, I don't have to do anything. To get from 2 to 2, I don't have to do anything. Same thing, 3 to 3, 4 to 4, 5 to 5. So to get from my n value to my numerator, I do absolutely nothing. Quite frankly, your numerator is your n value. So in this numerator, how to get that, or the rule for it, would just be n. So all you have to do is put n in the numerator. So then, in the denominator, looking at 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, if you notice any pattern, it's just one above your n value. So you would have to take n plus 1. So again, dealing with fractions, I would highly recommend doing what's going on top, what's going on bottom, and write those kind of as two separate rules there. Okay, one more. For this last one, let's do 2, 5, 10, 17. Again, on any of these, I would highly recommend you kind of pause the video, try to work these out on your own. So what I'm seeing is I am growing 1, not at a common rate. So I go up by 3, 5, 7. So the amount I'm going up by every time increases by 2. So it's kind of a steady rate, but it's also not. And I'm increasing relatively quickly. So I kind of have an idea that maybe there's an exponent going on here. But I'm also going up by such an odd number that maybe there's addition or subtraction also being included in here. So let's get our n values in. To try to write my a sub n. So what I'm looking at is this first term. And sometimes your first term is not your most helpful one. Your first term can kind of confuse you. So sometimes it's more helpful to jump a couple terms in and try to figure out, okay, looking at term number 2, how do I get from 2 to 5, 3 to 10, 4 to 17, okay? I always start with my first term, and then sometimes I say, my first term is really not helping me here. Let's go jump into my second, third terms. Okay, and that's the instance for this one. Because to get from 1 to 2, there's two things. Multiply by 2, add 1. But those two things are not going to work for any of the rest of these. Multiplying by 2 or adding by 1 will not work. Okay, for instance, 2 plus 1 is 3, not 5. But 2 times 2 is 4, not 5. So neither of those rules are working for me. So let's write a new one for 5. I was kind of on a right track when I was saying 2 times 2, but then I'm still going to get one additional thing in there to get to 5. So 2 times 2 is 4. I'm just missing a plus 1 to get to 5. So that was kind of awesome. That worked. Okay, let's see if it works with the other ones. 3 times 2 is 6, plus 1 is only 7, not 10. So it's also still not working. So maybe let's backtrack. How could this work with that first term? 1 times 2 plus 1 would be 3. So maybe 2 is not the number to multiply by. Maybe there's a different number to multiply by. Okay, let's think about 1 times 1 is 1 plus 1 would be 2. Okay, I know that 2 times 2 plus 1 worked here. So what about trying to multiply by my n value? Okay, it kind of seems like that pattern's happening. So 3 times 3 would be 9, plus 1 is 10. 4 times 4 would be 16, plus 1 is 17. Okay, so there's no exact way to kind of work out that thinking, but notice we just kept trying something. So we tried something with first term, with second term, with third, and we were like, ooh, let's backtrack a little bit. Try something different. And what we came up with was it was n times n plus 1, n times n plus 1, n times n plus 1. When you write n times n, sorry, I don't know why that was there, plus 1, n times n is simply n squared plus 1. Okay, so with these ones, I can only urge you to simply try these. If you aren't trying anything, you're not trying to make a rule for these, you will definitely not be successful whatsoever. Okay, there's no set way that I can say, well, if this happens, do this, and if this happens, do that. It's simply a problem solving and kind of critical thinking problem. So if you're not trying to solve these all on your own, you'll definitely run into some issues in trying to finally do these on your own on test. Okay. So that is series. I'm writing a rule for a series. I'm going to change one thing about what I have written up here and introduce a new small topic called summations. Okay, summation would be if I, instead of commas, had an addition sign in between all of these. I don't know if you can see that very well, but it is an addition sign. So instead of a sequence where I just take this number, that number, that number, that number, instead, I now took this sequence and made it into a summation by adding addition signs in between all of them. So what's kind of cool here, I'm going to remove the rule that we wrote for this. So what's cool here is I can actually find its sum. It would be super easy for me to say, well, let's see, 10 plus 17 is 27, plus 5 is 32, plus 2 is 34. And I could say, yay, that's the sum of this entire sequence and series. But that's not exactly going to help me for every single one. Okay, particularly, what if I added on and made it infinite? Now you're lost, right? You can't keep adding forever and ever and ever and ever. So that is why we introduce something called summation notation for series like this. So what happens is we have this uppercase sigma. And if you looked at this on the actual Greek letter, it would have little things hanging off the top and bottom of them. It basically kind of looks like a fancy looking E for that uppercase sigma. So on top is basically the number that we write for how many terms it goes. So for this case, we have 1, 2, 3, 4 terms. So I'm going 4 terms deep. The term I start at, in this case, is my first term. So that would be I equals 1. Because I started my first term, I equals 1. Because I go for 4 consecutive terms, that my last or total number of terms would be 4. Then I would have to say, well, how is this represented? What is the rule for this? That would be n squared plus 1. Okay, so the way I would write this out, if I was not given this, okay, let's go backwards and say, nope, I actually wasn't given that. All I was given was this summation notation. You would say, okay, let's fill in the gaps here then. Every time I start with my lowest number and plug that in for, and actually this should be an N. My bad. So sometimes you're going to see it I and I, sometimes you'll see it A and A, or K and K, or N and N. Whatever variable is written here should also be in that place. So we're going to say N equals 1 here. So I go through every term between my bottom term and my top term. So I would first start off by saying, okay, plug in 1 for N. So 1 squared plus 1. And then I have to add that to the next term. So now I'm on 2. 2 squared plus 1. And now I have to add that to my third term. Now I'm on 3, plugging the N. 3 for N. 3 squared plus 1. And lastly, I'm getting up to that top of my sigma. So I'm getting to the top of my bound, meaning 4 is as high as I can go. So now I'll plug in 4 for N. 4 squared plus 1. Notice what I just wrote back out was the 2 plus 5 plus 10 plus 17 to finally go ahead and get that summation of 34 here. Okay, so that is kind of just the ins and outs of summations and series. You can still write a rule for a series just like you would a sequence. So writing that rule is still going to be super important. But you also, again, have to be able to apply that rule given this summation notation, Okay, let's say that I changed this to a 12 and this to a 4. Okay, exact same series and exact same rule here. What would happen is I would go through the following numbers. I'm gonna start with my n equals 4. So the first one I'm writing is 4 squared plus 1. And then I would go up to 5 squared and 6 squared and 7 squared and 8 squared and 9 squared and 10 squared, 11 squared. The very last one that I would write would be 12 squared plus 1. Okay, I went through all the numbers 4 through 12. Okay, so again, starting number, ending number, how you're kind of applying that rule then in between. And you will, especially with these finite series, be able to find the actual sum to those summations and series. All right, that is it for this one. Let me know if you have any questions. Thank you for watching.